Permafrost is thawing in the Arctic and subarctic and causing ecosystem changes, structural damage, and releasing large amounts of carbon dioxide and methane into the atmosphere. Researchers have been working hard to understand more about permafrost changes and the long-term consequences for our world, but there is still a lot to learn and understand. Vast amounts of imagery has been collected by satellites, and researchers have created many different models for visualizing permafrost. But until now, there has been no way to get a more holistic view of big permafrost data on a global scale.
The Permafrost Discovery Gateway is an online tool that's in development and aggregates massive amount of permafrost data and different types of big data as well, from satellites and models, and it generates spatial information using machine learning techniques. And it's an open tool that everyone will be able to use and access and even contribute to. And it will provide powerful visualization and exploration features that will support scientific understanding of the Arctic.
On the Gateway, you can zoom into a specific area for a close perspective, view different types of data layers, and even download data to do your own analysis. One example of the type of visualization the Gateway will provide is through analyzing satellite images of features like ice-rich polygons. Polygon shapes are formed through the seasonal freeze-thaw cycle that affects Arctic soil over time, causing it to crack and buckle. The Gateway will be able to create sub-meter resolution vectors of polygon boundaries across the entire Arctic by employing machine learning. This is accomplished through a process of training the computer algorithms to interpolate the data to build better and more comprehensive models.
To make the algorithm predictions work well, we had to first augment the satellite images to enhance the clarity for neural network algorithm to work better. Then we had to manually train the algorithm by outlining more than 40,000 number of ice wedge polygons in a limited study area. Since there are so many high-resolution images that take up hundreds of terabytes of space, we had to break them into smaller regions for the algorithm to process more gradually. The polygon vectors are currently being generated across the entire Arctic using supercomputing resources.
This is just one example of the data visualization that the Permafrost Discovery Gateway, a National Science Foundation-funded Navigating the New Arctic program, will contain. Other layers include mapping surface water, biophysical zones, and a plot viewer that can help interpret data to foster a deeper understanding. As the development continues, our team will add additional layers to the Gateway, such as the LEO network, where crowdsourced permafrost news is aggregated from across the globe. This project will also offer features specifically designed for educators. Lesson plans will be developed that teachers can build upon that include learning activities for using the Gateway with students. An immersive experience is also being developed that will allow students to virtually visit some of the permafrost features and to connect deeper with permafrost land. Students might be able to virtually climb a pingo or visit the permafrost tunnel near Fairbanks, Alaska. Our hope is to create a comprehensive resource that will enable teachers and students to connect with real-world data and modeling to build excitement for the next generation of scientists, engineers, climate leaders, and policymakers. But we could really use your help. Are you a teacher passionate about climate change and learning about permafrost? Would you like to collaborate with a team of scientists to provide feedback during the development of the Permafrost Discovery Gateway? Are you interested in getting paid for helping create lesson plans? We have an opportunity to build these tools together and to apply for a grant for up to $15,000 to pay for your support. Please contact me, Jennifer Moss, at jlmoss@alaska.edu for more information about how to join our effort. I hope to meet you soon, and thank you for listening.